Alright, this is a video on Module 4, Section 10, Linear Inequalities. Linear inequalities mean you have order symbols like greater than, or equal to, less than, or equal to. That's the four we focus on here, but another inequality literally means inequality, not equal. Alright, so we don't really focus a lot on that one in this section, but these are specific not equals, alright, other than these two. But it means any one of these five symbols. Again, we're going to focus on the first four. Alright, graph the inequality on a number line. So the number line, if you're used to seeing it, number line, right, numbers get bigger as we go left to right. And we want to graph y is greater than 2. So I'm going to make this go both ways because technically it does. Alright, and then greater than 2, strictly greater than 2 means 2 is not included. So put a dash there, meaning there's 2. Put an open dot to indicate it's not included. So open, because 2 is not included. Alright, if we included 2, if this was underlined, then we'd have a closed dot. But since it's not included, strictly less than 2 means don't include 2. Alright, and then shade to the left. Where do the numbers that are smaller than 2 live? They live below 2. Alright, and then shade that arrow. Okay, so that's what we mean by graphing the inequality on a number line. Alright, this one, -1 is greater than m. Normally, to kind of get a number line correct, like graphing the number line correct, I tell people to flip this thing around. So if I flip this around, m is less than -1. Okay, the order symbol, right? But then I put m on this side, the number on this side. Don't worry about what it looks like right now, but just showing you that when I flip it around, the order sign flips when the number and the letter change places. So that's what you got to understand, is that when we do this, when we do inequalities, graph inequalities, it helps to put the number on the variable on the left side, the number on the right side. So here's -1. Right now the order sign is underlined, so that means it's equal to, less than, or equal to. So that means -1 is included. So I use a closed dot. So closed dot because -1 is included in our set. Okay, and then this time m is less than or equal to -1. So again, we're shading to the left side. Okay, so we're going this way with it. Alright, so if you put the variable on the left, you can think of this thing as an arrow pointing to which way you shade. But that's only if you put the variable on the left. And if you do switch the place of the variable and the number, make sure you switch the place of the order, or change the direction of the order symbol. Alright, now this is a between inequality. So when you make this, make sure you understand that the variable is between these two numbers. So it's smaller than smaller than 9, but it's greater than 4. Right? Now we have one of these open because it's not included, and then the other one closed because it is included, or it is underlined. So we're going to have an open dot and a closed dot. Alright, open dot occurs at 4, the closed dot occurs at 9, and we shade everything Alright, in between the two. Alright, now this is making our way towards an equation, or this is an equation, so or an inequality. So what I want you to understand is you work these exactly the way you would work it if it were an equation. So if this were an equation, like we've been doing, I want to isolate the x. I add the 4 over. Alright, and I get x equals -1. Alright, but the only thing different is right here in the middle is an inequality, greater than. Okay, but your job is still just like your job here was to keep the equal sign true by doing the same thing to both sides. Your job here is the same thing. Keep the order symbol true. Alright, meaning don't do anything to make the order symbol not true. Alright, so if this side is greater than this side and I add 4 to both sides, this side is still greater than this side because this side was more to begin with, and I added the same amount to both. So if it had more to begin with and we did the same to both, it's still greater than. So the only thing that's really changing is we keep the order symbol in the middle rather than an equal sign. Okay, so this is the new stuff and this is the old stuff, and I'm just showing you that we're not doing anything different. It's just kind of a different way to think about it. Instead of they were equal, they're going to stay equal. They weren't equal, but as long as we know who had the most to begin with, we still know who's got the most at the end. Alright, now here's the only time that this stuff changes from what we have been talking about. So to isolate, if this were an equation, to isolate the variable, I need to divide away the number in front. It's multiplication this time, not addition. So I would divide both sides by -5 to get that to go away, and I'd get x equals 25 divided by -5 is -5. Alright, so if we think of this problem like we did the last problem, then the only thing that happens is we have the order symbol down there, but that's not all that happens here. When we do division by negative or multiplication by negative to solve an inequality, that thing flips. So it was a less than or equal to, now it's a greater than or equal to. Alright, so the key thing here, and this is like by far the only thing really different from this and equations, is flip the order symbol. When you divide or multiply by a negative. Alright, and you only have to do that when you multiply by a negative. Alright, so let's try this one. Let's make this a little bigger so you can see it. Alright, solve the inequality again. Treat that like it's an equal sign. Distribute your 8 through. Alright, so I got an 8x plus 8 minus 7x, and then if I were treating it as an equal sign, I have to combine the like terms over here, so 8x minus 7x is just 1x, or just x. Alright, and then plus this 8 is greater than or equal to -9. And then finally, what would I do? I've got 8 being added to the x, so I need to subtract that away and do that on both sides. And I've got x is, I haven't divided by a negative anywhere in here, so greater than or equal to a negative minus more, still negative. 9 plus 8 is 17. Keep the sign of the two like numbers, and x is greater than or equal to -17. Alright, now the difference between this and previous problem is here, to get the x by itself, I divide it by a negative. Alright, so I flip the order symbol. But here, to get from where I started to where I ended up at this step, I subtracted. Alright, I subtracted 8. I did not divide by negative 8. I subtracted negative 8. Alright, so we don't flip the order symbol for subtraction, only for division or multiplication by negative. Only when you multiply or divide by negative. Alright, this problem. Alright, if I'm doing this, treating it like an equal sign at the beginning, I need to combine my like terms. There's no parentheses, so I combine my like terms. I get a negative 2x. It's less than or equal to x plus 2. Alright, and then I want to group the variables together, constants to the other side. Alright, so I need to subtract an x from the right to get no variables on this side. Okay, so negative 2x minus 1x, if you want to put a 1 there, that's a negative 3x, is less than or equal to 2. Alright, and then here we do it again. I got a negative on the side with the x. This is being multiplied here, so I can't add it away. I have to divide it away. So to divide it away, I have to divide by a negative. That's going to flip my order symbol. It was a less than or equal to, now it's a greater than or equal to. And that leaves me with x. And then a positive divided by negative is negative. And then 2 over 3, can't do anything with that, so we just write negative 2/3. Okay, we started off with a greater than, we ended up with a less than, we started off with a less than or equal to, we ended up with a greater than or equal to because we divided by a negative. Alright, treating this problem like an equation, I would distribute on both sides. 3 times x is 3x. 3 times negative 5 is negative 15. Less than symbol. 2 times 2x is 4x. 2 times negative 1 is negative 2. Alright. And now where do I want to group my variables? Now I can group the x's over here if you're trying to avoid dividing by a negative, but normally we write our solutions with the variable on the left anyway. So you'd still have to flip that order sign around when you put the x on the left, even if you did subtract 3x here. So again, it doesn't matter which way you move the variables, but because of the fact that this is an inequality, and normally we write inequalities with the variable on the left side, I'm going to move my negative 4x over this way. Alright, now I got a variable, constant, so I want to get rid of the constant on the right side, or sorry, left side, by adding it to the right side. Okay, gone here. The only thing left on the left is negative x. Negative 2 plus 15 is plus 13. Alright, and then I've got the opposite of the number I was looking for, and then a positive 13, so that means when I divide away the negative with the variable, my order sign flips, and I get x is greater than negative 13. And you just have to remember what an order sign means. Or, you know, what we were doing before was we were trying to find the one number that made the original thing true. But because it's an order sign now, there can be an infinite number of things that make it true. So pick a number that's greater than negative 13, like 0, and verify it makes it true. So 3 parentheses, I'm putting a 0 here where the x was. 0 minus 5. Alright, there's the original left side. The right side, 2 parentheses, 2 times, I'm letting x be 0, so 2 times 0 minus 1, close parentheses, and there's the original right side. And notice negative 15 is less than negative 2. This left side is less than the right side. left side less than the right side. Alright, and it'll work for any number that's greater than negative 13. If I plug in an 11 where the x is. Alright, 11 is greater than negative 13. Plugging in an 11 everywhere I see an x. Alright, once again I get this is less than this. The left side is less than the right side. Okay, but if I plug in something that doesn't satisfy this, like for instance negative 14, 3 parentheses negative 14 minus 5, there's the left side. Right, and then on the right side 2 parentheses 2 times negative 14 minus 1. Negative 58 is less than negative 57, so now this order symbol doesn't work. Right, the left side is not less than the right side, it's backwards. Okay, so that's what we mean by this is the solution. Anything that satisfies this will satisfy the original. Alright, things that got rid of fractions before multiplying by the LCD will get rid of fractions now. So the LCD on the left and the right of all the fractions is 6. If I multiply on the left by 6 and on the right by 6, right, 6 over 1 times 1/2, right, multiplying these two things together, 6 can be written as 6 over 1 times 1/2. The 2 will go into the 6 3 times. I'm left with 3 times 1 over 2, or 1 times 1. So I'm left with 3 times x minus 5 is less than, alright, same thing on the other side, 6 over 1 times 1 over 3. Alright, the 3 will go into the 6 2 times. And I'm left with 2 times 1 over 1 times 1, or just 2 times 2x minus 1. Alright, and now there's no fractions, so I can distribute 3 through, I can distribute the 2 through, and I have 3x minus 15 is less than 4x minus 2. Alright, looks very, very similar to this problem a couple of steps back. Or sorry, this problem at that point. So group your x's together. I'm going to show you, like if what I was talking about in the last one, if I choose to move my x's to the right side here to keep the sign in front positive, have negative 15 is less than 4x minus 3x is 1x, or just x minus 2, and then I add the 2 over to get the x by itself. So what I end up with is negative 13 is greater than x. Okay, but normally, now that it'd be fine if you wrote this as your inequality as your solution, but normally we put the x in front, and if we did put the x over here, the negative 13 over here, if we think this is an arrow, it's pointing at the negative 13, or if we think it is the hungry alligator, it's eating the x. If we flip the order around, we got to flip the order symbol around too. Alright, so it got flipped around just so I could put the x on the left. And again, normally because we read left to right, we put the variable on the left so we can read the order symbol as if we're reading left to right. X is greater than negative 13. Instead of saying negative 13 is less than x. But I mean, they're both the same. If you put this in, it would be fine. But just know the standard notation is to put the variable on the left. Alright. Same thing here. If I'm treating it like an equal sign, I need to distribute that negative 9 through. So I get a negative 9x. Negative 9 times negative 1 is positive 9. Alright, and then from here, group your x's. I'm going to add 9x. Again, when I'm doing inequalities, I move the variables to the left just to kind of get in that standard look to it. Alright, so I get negative x plus 9 is less than or equal to positive 9, or just, you don't need the plus sign, I could have left it off. And then again, I want to get the x by itself, so I subtract 9. Goes away on the right, and then remember, 9 minus 9 is 0, so don't make it into something else. Alright, and then the opposite of the number I'm looking for is less than or equal to 0. So if I divide away a negative, I get an x. Over here, 0 divided by anything is 0, but you divide it by a negative, so you got to change that order symbol. So x is greater than or equal to 0. Alright, now when you're doing this, for your answers, they talk about set notation, and they'll say write your answer as a set or give the solution set. Because there's more than one answer, a lot of times we write the answer in a set. You guys will just have to fill in a blank, so you'll just type in your answer. X is greater than or equal to 0. But just note that this is what we call the solution set, since there is more than one number that makes the original thing true now. Alright, word problem with a inequality, it just means that when you set it up, there's multiple things that could satisfy it. So these people are celebrating their anniversary. They've got this budget for their reception. They charge $90 cleanup fee plus $33 per person. Find the greatest number of people that they can invite and still stay within their budget. Okay? So what we mean here is, since this is my budget, if I don't want to spend all the way up to the budget, I don't have to spend every single last dollar, then as long as we stay less than or equal to that $2,000, everything's going to be fine. Alright, X is how many people we invite, so $33 per person means 33 times X is how much we had to pay for all people total. And then that set $90 cleanup fee, we add 90. So this is how much it costs to rent it, and then this is our budget. So we're staying less than or equal to our budget. Okay, and then to solve this, just subtract the 90. We get 33x is less than or equal to, when you do the subtraction, you get 1910, and then divide away the 33. X is less than or equal to 1910 divided by 33 is 57.87. And again, if you think about it, X has to be less than or equal to that. Okay? This is the number of people that we're going to invite. It doesn't make sense to invite a fraction of a person, so X has to be less than or equal to that, so we would say X is less than or equal to 57. Okay, because if we round it up, the or equal to wouldn't need to be included. So we could say this, and then technically we could also say, if we did round it up, we could say X has to be less than, strictly less than 58. Okay, because now the first number less than this is 57. So these are both technically the same, but this would be what they would be looking for, because they want to use the same order symbol you set it up with. Alright, a 150-pound person uses 6.3 calories per minute when walking at that speed. How long must a person walk at this speed to use at least 240 calories? Alright, at least 240 calories. At least means, or another way to say at least is greater than or equal to 240. Okay, so at least, that's where I'm getting this from. Alright, now 6.3 calories per minute, so I'm using 6.3 calories for every minute that goes by, and I want to use greater than or equal to 240. Alright, notice this 4 miles an hour, that's not being put in here. This 150 miles an hour, that's not being put in here. This 150 and the 4 is where the 6.3 is coming from. Okay, and I'm not like dividing or anything. I'm just saying that for a 150-pound person walking this speed, they're burning this many calories per minute on average. So that's where this number's coming from. That's why you're not using these numbers. All right, and then how do I solve it? I isolate the variable, so I just divide away 6.3. So x is greater than or equal to 240 divided by 6.3, 38.095, so .1 minutes. Okay, how do I know it's minutes? Because it's calories per minute. Now this is something just everybody who takes college course should know how to do. Alright, if I know what my test grades or whatever goes into making your final average, if I know what those things are, what do I need to have an average above a 90 or an A or a B if it was an 80? Alright, what should I get on this final exam? So the way these problems work is you got 1, 2, 3 tests so far. You're getting ready to take your fourth, and you want your average to be 90. Well, how do you get an average? You take the numbers, you add them up. Alright, we don't know what the last one is, so x, you divide by how many things you just added. We just added up 4, and it needs to be above a 90, so greater than 90. So there's our setup. Okay, there's what we're solving for. Add all these other numbers up. 84 plus 88 plus 91 is that. Okay, so 263 is being added to x. So x plus 263 divided by 4 is greater than 90. Alright, and now just clear out fractions. The only fraction here is 4, so we're going to multiply both sides by 4 to get the fraction out. And I got x plus 263 is greater than 90 times 4 is 360. Subtract 360. Oops. Subtract 263 from 360. Alright, that's gone, and I get x has to be greater than, do this subtraction, and you'll get 97. So to average above a 90, they've got to score almost a perfect score on that last one. Alright, way to check it. Add up. Oops. The last thing we just did was this. Add 97 in there. Divide by 4. That's exactly 90. So if I add just a tiniest little bit more than 97, like a 97.1, alright, and divided by 4, now I'm a little bit bigger than 90. Okay, so greater than 90, that's greater than 90. So that means, looks like we did it right. Alright, last example I'm going to give you in this section. A bank offers 2 checking account plans. Anywhere plan charges 30 cents per check, whereas the Accu checking plan costs $1.92 per month, but only 18 cents per check. How many checks will the Accu plan cost less? So this 18 cents per check, that's cheaper than this 30 cents, but because of that upfront fee, it's going to take a while for this to start being cheaper. So the setup here is we want the Anywhere plan, or sorry, the Accu plan to be less. So Accu is less than Anywhere. Okay, that's what we're looking to find. Now, X is the number of checks. Why am I letting X be the number of checks? Because look what it asks. For what number of checks? Okay, so X is the number of checks per month. Alright, the Accu plan, that's this one. $1.92 per month, that's the upfront cost. plus 18 cents per check. So for every check that I write, it's 0.18x the number of checks, so 0.18x. And that's less than the Anywhere plan, which is 30 cents per check. So that's 0.30 times x. Okay, so there's your setup. Your job is to solve for x. So I'm going to, because it's only one step away, even though I said I normally put the x on the left, but 0.30x to minus 0.18x is 0.12x, and then I'm going to divide by 0.12. Alright, so the only reason I move the x's to the right is just because it was one step and then I'm dividing, rather than having to move this over and then move this over and then divide. I just subtract over the 0.18 and then I'm dividing. Alright, so not dividing by a negative, so that stays x. And then 192 divided by 0.12 is 16. Alright, so 16 is less than x. If I flip the x over here, the 16 over here, I have to change the order sign. Okay, it's pointing towards the 16, so it needs to point towards the 16 here as well. So I need to use more than 16 checks. For that one to be less. Alright, and that's last example of 410. Most of the ones that are set up like this, you just have to look for what you're actually setting up in the wording of the problem. It won't always just say cost less. They'll have keywords that you got to look for. Above, right? At least we said it's greater than or equal to. At most would be less than or equal to. Alright, so just be aware of your order symbols when you're making your setup.